Imagine orbiting Earth at speeds faster than a speeding bullet. Now, imagine tiny fragments, some no bigger than a screw, also zipping around at those same insane speeds. What happens when they hit? It can be catastrophic. Welcome back to Sciencepect, where we explore the frontiers of science, technology, and space. Today we're looking at a hidden crisis happening high above our heads, the space debris problem. Is Earth's orbit becoming too dangerous? And what can we possibly do to clean up this celestial junkyard? For decades, humanity has been launching rockets, satellites, and probes into space. Each launch, each mission, each test has left behind a legacy, not just of exploration, but of garbage. We're talking about defunct satellites that failed or ran out of fuel, discarded rocket stages, pieces of insulation, nuts, bolts, and worst of all, thousands upon thousands of fragments from collisions and intentional destructions, like anti-satellite missile tests. Currently, space agencies track over 30,000 pieces of space debris larger than 10 centimeters. But estimates suggest there could be millions of pieces between 1 centimeter and 10 centimeters, and literally hundreds of millions smaller than a centimeter. While tiny, even a paint fleck can cause significant damage. When traveling at orbital velocities, which can reach up to 17,500 miles per hour in low Earth orbit, that's like hitting a bullet with a bullet. The risks are clear. Active satellites, those providing GPS communication, weather data, and scientific research, are constantly in danger. A collision can damage or destroy them, leading to loss of vital services and creating even more debris. Think about the International Space Station. It has to perform evasive maneuvers surprisingly often to avoid potential collisions with tracked debris. But the biggest fear, the real nightmare scenario, is something called the Kessler syndrome. Proposed by NASA scientist Donald Kessler in the 1970s. This theory suggests that if the density of objects in low Earth orbit reaches a certain point, a single collision could create enough new debris to increase the likelihood of further collisions. Each subsequent crash would then generate even more fragments, leading to a runaway chain reaction. Eventually, certain orbits could become so saturated with debris that they're essentially unusable for future satellite deployment or even safe passage for generations. This isn't just a theoretical worry anymore. With the explosion of mega constellations like Starlink and others placing thousands of satellites into orbit, the risk is increasing. So how do we deal with a problem that's literally flying around the planet at incredible speeds? Well, there are two main approaches: prevention and active removal. Prevention is the first line of defense. This involves designing new satellites and rockets with end-of-life plans. For satellites in low Earth orbit, this usually means performing a controlled deorbit burn to ensure they burn up safely in the atmosphere, or at least bringing them down quickly within 25 years as recommended by international guidelines. For satellites in higher orbits, where atmospheric drag isn't enough to bring them down, the solution is often to move them to a graveyard orbit, a stable orbit far away from operational satellites. Implementing these practices universally is key, but it requires international cooperation and commitment. But what about the hundreds of thousands of pieces of debris already up there with no deorbit plans? This is where active debris removal, or a DR, comes in. This is one of the most exciting and challenging areas of space technology today. Scientists and engineers are proposing and testing a variety of ingenious methods to grab, move, or otherwise eliminate space junk. One concept is the space net. A dedicated cleanup satellite could launch a large net to capture one or more pieces of debris, then either bring the captured junk into the atmosphere to burn up or deposit it safely in a graveyard orbit. Missions like the European Space Agency's Remova Debris project have already successfully tested this technology in space. Another method uses robotic arms, similar to those used on the International Space Station. A robotic arm could grapple onto a piece of debris, allowing the cleanup satellite to stabilize it and then initiate a controlled deorbit. Companies like ClearSpace SA are planning missions specifically using robotic arms to capture and deorbit defunct rockets. How about lasers? The idea here isn't to blow up the debris, but to use a powerful laser pulse to slightly heat one side of a piece of debris. This heating causes a small amount of material to ablate, creating a tiny thrust that can gently push the debris into a lower orbit, where it will eventually re-enter and burn up. This could be done from ground-based stations or potentially from a spacecraft. For conductive debris, like old rocket bodies or satellite components, magnetic capture is being explored. A spacecraft could use powerful electromagnets to attach to the debris and then tow it to a disposal orbit. Finally, there are concepts like drag sails or tethers. These aren't typically used to capture existing debris, but they could be attached to large pieces of debris or integrated into future satellites before launch. Once attached, the sail or tether increases the surface area or drag profile of the object, causing it to be slowed down by the faint upper atmosphere and deorbit much faster than it naturally would. Each of these technologies has its own challenges. They need to be able to capture objects that are tumbling uncontrollably, withstand the harsh space environment, and do so economically and safely without creating more debris. International laws and ownership issues also complicate the picture. Who owns the junk and who has the right to remove it? Solving the space debris crisis requires a multifaceted approach. Strict adherence to prevention guidelines for new launches, continued research and development into active removal technologies, and crucially, international cooperation to establish clear rules and responsibilities for cleaning up orbit. The future of space exploration, satellite-based services, and even scientific understanding of our universe depends on our ability to be good stewards of the space environment around our planet. It's a complex problem, but with innovation and collaboration, the prospect of a cleaner, safer orbit is achievable. What do you think about the technologies we discussed? Are there other solutions being developed that we missed? Let us know in the comments. If you found this video informative, please give it a like and share it. And don't forget to subscribe to Sciencepect for more deep dives into the cutting edge of science, technology, and space. Just click that subscribe button right here. Thanks for watching, and we'll see you in the next video.